Hello everyone, I'm Jayesh Nafre and today we will be talking about flow control mechanisms in computer networks. This is the DA2 of computer networks. So, so let's start with what is flow control. Flow control is a technique which is used in data communication. It basically controls the rate of data transmission between sender and receiver. It also prevents the sender from sending too much data too quickly. Also, it ensures reliable data delivery. Flow control ensures that the receiver can process incoming data without losing information. If data arrives faster than the receiver can handle, packets may be dropped. Now let's go on to need for flow control. So why is flow control important? So what happens is that sender and receiver operate at different speeds. The receiver buffer may become full at some point of time, and because of that, data packets may be lost. Uh, by using flow control, we can improve the reliability of communication. For example, we have here is that high speed server to low speed device connection. Different devices operate at different speeds. If the sender transmit too fast, the receiver may not handle the data. Flow control basically ensures reliability and smooth communication. Now let's go over to types of flow control. So there are mainly two types. First is the stop and wait flow control, and the second is the slide window flow control, which is also called as sliding window protocol. The let's just do a brief introduction about stop and wait, and then we will go to the sliding window protocol. The stop and wait flow control basically sends one frame at a time, whereas the sliding window allows multiple frames to be sent before acknowledgement. So now let's start with stop and wait protocol. So basically, what happens is that sender sends one frame at a time. Then then it waits for the acknowledgement. So if the acknowledgement gets received, it will send the next data frame, and if not, then it will retransmit the lost frame. The advantages of this type of protocol is that it is like very simple to implement, but the disadvantage is that it's very slow and it has a very low efficiency. Now let's start with the main topic, which is the sliding window protocol. So now you may ask, why should we use sliding window protocol? This is because it's used for efficient data transmission. The main selling point about this protocol is that it allows multiple frames to be sent before acknowledgement. Also, the main special thing about this protocol is that it maintains a window size, and then as the acknowledgement are received, the window slides to the data frame. Here, the sender can send several frames continuously without waiting. The receiver acknowledges the received frames, and the window moves forward. This is the basic diagram of sliding window protocol. As we can see in the first diagram, here the window size is 1, so it sends one data frame and then it waits for the acknowledgement, then it again sends. It's basically like what we say, stop and wait ARQ. The second one has a window size of 4, so it sends multiple frames at a time without waiting for the next frame. And the moment it gets acknowledgement for one of the frames which was sent earlier, the window shifts and the other frames get sent. So here they are like six. The window size is 6. So yeah. Now let's understand the working of sliding window protocol. So these basically are the steps for the sliding window protocol. First is that the sender sends frames within window size. Then the receiver receives frames and sends the acknowledgement. Then the windows moves forward after the sender receives the acknowledgement, and then the sender sends the next set of frames which are in the window. Now, like for example, suppose the window size is 4, the sender sends frames 1, 2. Then after receiving the frames for 1 or 2, it shifts and like now the window is like 3, 4, 5, 6. The advantages of sliding window is that yeah, so like there are many advantages. The first being the efficient use of the bandwidth. The second is the higher data transmission speed. Third is the reduced reading time, and fourth is the better network utilization. So yeah, in short, sliding window is very much better than the stop and wait ARQ. Now let's understand error control in sliding window. So in sliding window there are two protocols which handle errors. First is the go back NRQ, and second is the selective repeat ARQ. So now you may ask, what is ARQ? ARQ is basically automatic repeat request. It is basically used to detect and retransmit the lost frames. Now let's start with the first one, which is the go back and protocol. Here, what it does is that the sender sends multiple frames. The receiver accepts frames in order, and then suppose if one frame is lost, all subsequent frames are rejected. So like suppose suppose we have a window size for 1, 2, 3, 4. One gets sent, two gets sent, three gets sent. So acknowledgement for the first comes, but for the second one, the acknowledgement doesn't come. So all the remaining frames which are 2, 3, 4 gets rejected or discarded. And then the sender retransmits all from the lost frame, again from the lost frame. Like suppose this is the diagram. As we can see here, the window size for at the start is 0, 1, 2, 3. It sends the 4 frames. The acknowledgement for 0 and 1 comes, but the acknowledgement doesn't come back for frame 2, and therefore the remaining frames, that is frame 3, 4 and 5. 4 and 5 because we get the acknowledgement for 0, 1, so it sends the 4 and 5 frame. But 3, 4, 5 are discarded, and it sends again from the lost frame. That is, it's retransmit from again from the lost frame, which is 2, and then 2, 3, 4, 5. As we can see, 0, 1, 2, 3 was sent. Acknowledgement for 0 and 1 return, and hence frame 4 and 5 are sent. But frame 2 is lost. So since it's a go back and ARQ, the receiver discards the frames 3, 4 and 5, and then retransmits the frame 2, 3, 4, 5 again. The advantages of go back and is that it's simple to implement. Second is that the less receiver memory is required in this. And third is the easy error detection. Now, as it has advantages, it also has disadvantages. Here, the system retransmits many frames unnecessarily. Suppose we don't need to retransmit 4 and 5 in the previous example, but we still did. Because of that, there is a bandwidth wastage, and it is basically inefficient when error rate is high. When suppose multiple frames get lost or multiple acknowledgement doesn't come back, the error rate is high and like it's very inefficient. The second error control method is the selective repeat protocol. This is the upgraded version of the go back and ARQ. It's advanced. It is the advanced version of it. Here only the lost frames which are actually lost are retransmitted, not the whole entire series of it. Here the receiver stores out of order frames, and in this the it uses separate acknowledgement for each frame. So this is a diagram for the selective repeat protocol. As we can see, it's the same example as the previous one. Frames 0, 1, 2, 3 are sent. The acknowledgement for 0 and 1 turns back, but uh, the acknowledgement for 2 doesn't come. As the acknowledgement for 0 and 1 come back, 4 and 5 frames are sent, and also the frame 3 also gets the like acknowledgement of frame 3 also returns. So we only retransmit the lost frame, which is the second frame. That's why, as we can see here, the second frame is sent, and 4 and 5 return back, and then 6 and 7 are sent. Like, see, yeah, this is the example. Frames 0, 1, 2, 3 are sent. The acknowledgement of frame 0 and 1 return, and then 4 and 5 are sent. But the frame 2 is lost. So since it's a set to repeat ARQ, the receiver stores frame 3 and the sender retransmits only frame 2. Now, the advantage of selective repeat is efficient bandwidth utilization. Also, it retransmit only lost frames. Whereas in the case of go back and ARQ, it retransmit the entire series of the lost frames, like starting from the lost frame and then the entire window. But here it only retransmits the lost frames. Because of that, it has a higher performance in like noisy networks and all. So yeah. Now the disadvantage of selective repeat is that it's not simple to implement. It has a more complex protocol. It requires more memory, and the receiver must buffer out of order frames. This is the difference between go back and selective repeat. Uh, as we can see, for go back and ARQ and for selective repeat, the retransmission feature in go back, the all frames after loss, like the go back and ARQ retransmits all the frames after the loss, whereas in the selective repeat, it only retransmits the lost frame. The efficiency of go back and ARQ is comparatively low compared to the selective repeat, as the selective repeat has higher efficiency. The complexity is simple in go back end, whereas it's complex in selective repeat. And in go back and ARQ, receiver buffer is small, whereas selective repeat it is very large. Now let's go over the applications of flow control mechanisms. So flow control is used in TCP, which is the transmission control protocol. It is also used in internet data transfer, file transfer protocols, and wireless communication. Also in network data reliability. So the real world example of flow control is that let's suppose we take an example of faster computer networking with the stored mobile device. Without the flow control mechanism, there will be a data overflow, packet loss. But with the flow control mechanisms, there will be controlled transmission and reliable communication. So if suppose if the computer sends data too quickly, the mobile data device may not be able to process it, which can cause packet loss. And so after enabling flow control, it ensures that the data is sent as at a speed that the receiver can handle, ensuring reliable communication. Now let's now the conclusion occurs. So like let's do a quick summary of everything. So why is so like the importance of flow control computer networks? It flow control is essential in modern networking systems as it prevents data loss by controlling transmission speed. It improves the reliability of communication between devices, and it also ensures efficient data transfer. Flow control help, and it also helps in maintaining stable and efficient networks performances. Also, let's get over the definitions. We already know, but still, in data communication, information is divided into small units called frames before transmission. Each frame is assigned a sequence number so that the receiver can identify the correct order. When the receiver mm, can, when the receiver successfully receives the frame, it sends an acknowledgement. This acknowledgement informs the sender that the frame was received correctly and at time. Now let's go over the sequence numbers. So basically, sequence numbers are used to uniquely identify each frame during transmission. They help the receiver detect duplicate frames. They help the receiver detect duplicate frames and maintain the correct order of data. In sliding window protocol, sequence numbers play an important role in tracking which frames have been sent and which ones have been acknowledged. Also, there are two windows. First is the sender window, and the other one is the receiver window. So, in sliding window protocol, both the sender and receiver maintain a window. The sender window contains frames that the sender is allowed to transmit, and the receiver window contains frames that the receiver is ready to accept. As frames are acknowledged, both windows move forward, allowing more frames to be transmitted. Then let's go over the importance of flow control. Not like now we have gone through everything. So, there's stop and wait, and then there's sliding window. Then in sliding window, there's like two ways to handle error control. First is the go back and ARQ, and second is the select to repeat. In go back and ARQ, uh, you transmit from onwards the lost frame, and in select to repeat only transmit the lost frames, only the lost frames. Go back and ARQ is simple to implement, whereas select to repeat is complex. So basically flow control prevents data overflow, sliding window increases efficiency. Go back and retransmits multiple frames. Then selective repeat retransmits only lost frames. And these protocols, in general, ensure reliable communication in advance. So yeah, to summarize this, these mechanisms play a vital role in ensuring reliable and efficient communication in computer networks. So yeah, with this we have come to end of our lecture of flow control mechanisms. I hope you enjoy it. I hope you enjoy watching it. So, thank you.